Alright, so we're going to solve an initial value problem using trig substitution. So here we have the square root of x squared minus 9 times dy over dx equals 1. X is greater than 3, and y of 5 is equal to the natural log of 3. So first things first, we've got to isolate the y and x terms to either side of the equation so that we can integrate both sides. So let's multiply by dx over the square root of x squared minus 9. Let's write that better. X squared minus 9 on both sides. Which will give us dy equals dx over the square root of x squared minus 9. Now we can integrate both sides. The integral of dy is equal to the integral of dx over the square root of x squared minus 9. What we'll get is y is equal to the integral of dx divided by square root of x squared minus 9. And now what we can do is use our trig substitution, because the square root is essentially a triangle. You can think of it in terms of a triangle. So we have the square root of two squared terms, x squared and 3 squared, and they're being subtracted. So this is very much like the Pythagorean theorem, a squared plus b squared equals c squared. Now if we were to subtract a side from the hypotenuse, we would, and then take the square root of both sides, we would, to find the length of a single side, we would result in a square root that looks something like this. So x is the hypotenuse, and then one of the sides is the square root, and the other side is 3. And it's arbitrary which side we choose, so we choose it out of convenience. In this case, we'll want the bottom side to be 3, and we'll want the opposite side to be x squared minus 9. Because in this way, secant theta will be equal to x over 3, which is easy to work with, and x will be equal to 3 secant theta. So dx will be equal to 3 secant theta tangent theta d theta. Now we can plug that into our integral. So what we'll get is y is equal to the integral of our dx is now 3 secant theta tangent theta d theta divided by the square root of x squared. Our x is 3 secant theta squared minus 9. Now we can start simplifying this. This will be equal to 3 secant theta tangent theta d theta and we can square the inside to get 9 secant squared theta minus 9, which will be equal to the integral of 3 secant theta tangent theta d theta divided by the square root of, we'll factor out this 9 times secant squared theta minus 1. Now, secant squared theta minus 1 is equal to tangent squared theta. That's part of the Pythagorean identities of the trig functions. So this will result in 3 secant theta tangent theta d theta divided by the square root of 9 tangent squared theta, which will be equal to 3 secant theta tangent theta d theta divided by, taking the square root, we'll get 3 tangent theta. And this is convenient because the tangent theta and the 3 will cancel. So the integral will finally be left as secant theta d theta, which will be equal to the natural log of secant theta plus tangent theta plus c. Now, we're not done yet. We've got to put our function back in terms of x, because we're in terms of theta right now. So this will be equal to the natural log of x divided by 3, because that's what secant is. Remember up here, secant is x divided by 3, and our tangent theta will be equal to the square root of x squared minus a divided by 3. Excuse me, because it's opposite over adjacent. So it'll be x divided by 3 plus the square root of x squared minus 9 divided by 3 plus c. Now we're still not done yet. We have to find out what this constant is, and we'll use these values here to find that out. So when y is 5, function results in the natural log of 3. So let's plug in 5 for x. We get the natural log of 5/3 plus the square root of 5 squared minus 9 divided by 3 plus c. So the natural log of 3 will equal the natural log of 5 plus the square root of, what's that, 16 over 3 plus c, which will equal the natural log of 5 plus 4 divided by 3 plus c, which will equal the natural log of 3 plus c. So if that's the case, then c must be equal to 0, which is convenient. And our final answer is y equals the natural log of x divided by 3 plus the square root of x squared minus 9 divided by 3.